Next is about fatigue strength. Repetitive stresses sometimes cause the failure of a structure, even if the stresses are within the elastic ranges in the stress-strain diagram. This failure is called fatigue failure, and the fatigue strength is a property to examine the phenomena of failure. Various accidents have occurred in the past due to fatigue failures. For example, there was the JAL jump crash in 1985, and mechanical parts have broken under unexpected conditions in other cases. I used to be a design engineer of automotive parts, and most of my practice used to be countermeasures against fatigue failures that have occurred unexpectedly. So far, it has been emphasized that the key factor of a machine design is to select dimensions, shape, and materials so that materials do not exceed the elastic point with respect to rigidity, strength, hardness, and ductility. Even if a machine designer believes that the design is perfect, the fatigue failure sometimes causes in unpredicted troubles in machines. Fatigue failure is a very tricky problem. If the too large a safety factor is taken, the entire structure can become unnecessarily large. However, even if it does not fracture under normal use, it may unpredictably fail caused by unexpected repetitive loading. Fatigue is assessed by the magnitude of load and its number of repetitions. Based on the assessment, you may design the stress applied to a mechanical part subjected to repetitive loading. A diagram which is called SN diagram is used to evaluate fatigue. In SN diagram, the stress is taken at the y-axis. The number of repetition of loading is taken on the x-axis. In a machine design, the main principle is to make stresses within the elastic range. I have already explained that repetitive loading may cause fatigue failure. Here, it is known that fatigue failure does not occur as long as the stress is below a certain magnitude. This is called fatigue limit. In case of a part subjected to repetitive loading, the stress should be designed to be below the fatigue limit. The concept of fatigue limit is aiming at controlling fatigue. In the case of mild steel, the fatigue limit clearly appears. On the other hand, in the case of non-ferrous metals such as aluminum, the fatigue limit does not clearly appear. When using non-ferrous metals, you should design the stresses so that the part withstands a sufficient number of repetitions in the operating environment. So, what may be countermeasures against fatigue failure? Fatigue failure is a phenomenon in which small cracks progress from a defect on the surface or inside of the structure and eventually resulting in the failure. From this point of view, a simple countermeasure is to reduce the number of starting points that progresses the cracking. For example, you may design a larger corner radius. It is also important to prevent internal defects such as cracking and impurities caused in casting. Heat treatment may be implemented for homogeneous crystalline structure and hardened surface.